Hello everybody, welcome into another lesson. So today we are going to use more than one pair of congruent triangles to do some proofs. The lesson's going to consist of 5 proofs, that'll be it. There are no new theorems or postulates or corollaries or definitions. So you can kind of consider this a review of everything we've learned up to this point, only we're going to be using more than one pair of congruent triangles. Here pictured we have triangles RNX and LOY. They are split each into 2 separate triangles. We can clearly see that RNX is congruent to LOY. In fact, that's given to us. What we need to prove is that side NE is congruent to side OS. So where do we begin? First, of course, we want to state the given information that triangle RNX is congruent to triangle LOY. The reason, of course, that was given to us. Alright, so where do we go from here? Where do we go from here? If these 2 triangles are congruent, right? The 2 big triangles are congruent. Wouldn't it be true that angle X is congruent to angle Y? It would, because of CPCTC. So the next thing you would say is that angle X is congruent to angle Y by CPCTC, otherwise known as corresponding parts of congruent triangles are congruent. Okay. Now we've proven X and Y congruent by CPCTC. Now look at triangles NEX and OSY. Each of them have a side, angle, and side congruent to each other, right? So our very next step is to say that triangle NEX, triangle NEX is congruent to triangle OSY by the side angle side postulate. And then, if these 2 triangles here are congruent, we could then argue that NE is congruent to OS by CPCTC. So that leads us ultimately to what we're trying to prove is that NE is congruent to OS by CPCTC. So I'll go through this proof again here real quick. So we were given 2 triangles that were each split into 2 triangles, so really we have 4 triangles to work with. And what you have now, you were given that triangles RNX and LOY are congruent to each other, which was our first statement. We ultimately want to prove that NE is congruent to OS. We already stated the given information in the first step. Second step, then, we can conclude that angles X and Y are congruent to each other because of CPCTC, which then could lead us to conclude that triangles NEX and OSY are congruent by the side angle side postulate, and then that would lead to NE is congruent to OS. Now, I'm going to show you a minor tweak here. There's another way you could have done this proof. There's absolutely a second way you could have done this proof. What I'm showing you is one way. I'm going to show you another way. So if the 2 master triangles are congruent, isn't it also true that angles R and L would be congruent to each other? By the same reason. Angle R would be congruent to angle L by CPCTC. If you chose to go that route, well then notice triangles RNE and L, O, S. You still have a side, angle, and a side. So since you have that congruency, you can then say triangle NRE is congruent to triangle LOS by, once again, the side angle side postulate. Which then, now you can conclude that NE is congruent to OS by CPCTC. So, really, there were two ways to do this proof. And I just showed you both ways. So depending upon which route you wanted to go, you would arrive at the same reasoning, same proof, no additional steps. It was really up to you how you wanted to prove it. So, there's that one. Let's go on to the next problem. The next proof, I should say. What do we got here next? Alright, so we have that. Have a diagonal going from there to there. And then we have from here to here. Okay. Let's label our points. Here's point E right there. This is F, D, C. We're even given that these are perpendicular here. We're given angle 1 there, angle 2 here, and we're given even some congruent sides. Okay, so let's see what we've been given here. We have been given that triangle ADC is congruent to triangle CBA. So we're given that triangle ADC is congruent to triangle CBA. If you look at this once again, this is one triangle split into really split into 4 triangles. Don't let these overwhelm you when you see multiple triangles, because up to this point we've only compared 2 triangles. Now we have more than 2, we got to suddenly still figure out congruencies and proofs. But what are we seeking to prove here? The proof is going to be that BE is congruent to DF. We have to prove that. So I'll go ahead and set up our columns again here. Alright, statements and reasons. Of course, we'll start with the very first statement, that triangle ADC is congruent to triangle CBA. That, of course, was given to us, that the 2 triangles were congruent. where do we go from here? Where are we going to go from here? Well, it looks to be that angles 1 and 2 are corresponding angles, right? So we can now say that angle 1 is congruent to angle 2 by CPCTC. Corresponding parts of congruent triangles are congruent. So now we've concluded angle 1 is congruent to angle 2 by CPCTC. Alright. So, let's now look at triangles ABE and then triangles CDF. Triangles ABE and CDF. We notice here we each have an acute angle and the hypotenuse congruent, right? At this point, we can actually go ahead and say that triangle ABE is congruent to triangle CDF by the HA theorem, or the hypotenuse acute angle theorem. Because each of those right triangles have the hypotenuse and an acute angle congruent, so therefore we can prove ABE and CDF congruent. And then last but not least, BE and DF are corresponding parts of those two triangles that are congruent, so we can therefore say that side BE is congruent to side DF by the fact of CPCTC. So let me go through this proof again here. We were given that triangles ADC and CBA, the two triangles, the two big parts, they're given information to us that they're congruent. And if those two triangles are congruent, then we can say angle 1 is congruent to angle 2 by CPCTC. Now, if we look at just triangles ABE and CDF, we have the hypotenuses congruent and an acute angle congruent. So therefore, triangle ABE is congruent to triangle CDF by the HA theorem, the hypotenuse acute angle theorem. Which, last but not least, we can ultimately prove that BE is congruent to DF by CPCTC. So that's how sometimes you can break all these multiple triangles up. First, start by looking at the big picture, and then you can start going into the smaller pieces. Usually it helps to look at the big picture first when you're given multiple triangles. All right, proof number 3. See what else we've been given here. We label the vertices R, G, J, A, K, N, and then what's the far right one? T. Let me place the congruency markers where they go. Here, 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 and then here. All right. There's all our congruency markers. So let's see what we've been given. What have we been given? that triangle RAJ is congruent to triangle NAK. What we have to prove is that angle G is congruent to angle T. So we are given that triangle RAJ is congruent to triangle NAK. We have to now prove that angle G is congruent to angle T. Alright. Let's go ahead, set up our two columns again here. Okay, so let's start with our first piece of information here, that triangle RAJ is congruent to triangle NAK. So triangle RAJ is congruent to triangle NAK, of course, by the given information. Alright. Now, where do we go from here? I think it's plain to see we have two vertical angles here, right? And we know that vertical angles are congruent, so we can now say that angle RAJ is congruent to angle NAK by vertical angles are congruent. Alright. We would also, since these two triangles are congruent, wouldn't it be true that JA would be congruent to KA? So JA and KA are congruent by CPCTC. JA is congruent to KA by CPCTC. Okay, where to from here? So let's look now. These look like two triangles here split into two, don't they? If you consider each whole triangle, you have a side, an angle, and a side that are congruent to each other. So we can actually now say that triangle GRA is congruent to triangle TNA. We could say that by the side angle side postulate. Which then, last but not least, we can now say that angle G is congruent to angle T by CPCTC. Alright, so let's go through this proof again here real quick. We start out being given that triangles RAJ and NAK are congruent. That was given to us. We notice right away that angles RAJ and NAK are congruent to each other due to the fact that they're vertical angles, and vertical angles are congruent. Now, if triangles RAJ and NAK are congruent, that means JA is congruent to KA because they're corresponding parts of congruent triangles. And then if you take a step back and look at the whole picture, consider these as two triangles. You combine each half, you can say triangle GRA is congruent to triangle TNA by the side angle side postulate, which would then lead you finally to conclude that angle G is congruent to angle T by corresponding parts of congruent triangles are congruent. So sometimes you also work in reverse. You start smaller, then get bigger. It's just a matter of being able to discern which way the proof is leading, which way the diagram's leading. Alright, I have 2 more proofs, then we're done for the day. Another one here, like this. This time the diagonal's going this way. Oh, that was terrible. That's not what I wanted to do. I was off kilter a little bit with my drawing. Okay. Then what else are we given here? Alright. Then we have, let's see, DAL. DA, here's point L. MCB. MC and B. Alright, so there's all our vertices or points labeled. Now let's set up some congruency markers. This side's congruent to this side. You have this angle congruent to this angle. You have this angle here congruent to this angle here. And then you have angles 1 and 2. Let's see what we were given first. What have we been given? We are given that triangle ABD is congruent to triangle CDB. What we ultimately are seeking to prove out of this is that AL is congruent to CM. Alright, so we've been given that triangle ABD is congruent to triangle CDB. We now have to prove that AL is congruent to CM. So let's go ahead and set up our 2 columns. This is one of those proofs here based on the diagram that looks a lot worse than it really is. It's really not as bad as it looks. Again, don't let multiple triangles intimidate you, okay? So let's start with our first statement, which will be the given information, that triangle ABD is congruent to triangle CDB. That, of course, the reason it was given to us. Where do we go from here? Where should we go from here? Well, let's look at something. If these two triangles are congruent to each other, then wouldn't AD, that would mean that side AD is congruent to side CB by CPCTC. So by corresponding parts of congruent triangles are congruent, you can say AD is congruent to CB. I placed the congruency markers there for us to give us a hand with that. There's another thing we can say. You could have combined these actually both into step 2, but I'm trying to really illustrate a point here. It's also true that angles 1 and 2 are corresponding angles, right? You could even say that angle 1 is congruent to angle 2 by CPCTC. So that's why we could have combined them into one step, but I'm trying to take these a piece at a time here. Alright. So now if we look at triangles ADL and then CBM, triangles ADL and CBM, in each of these we have an angle, side, and angle congruent, right? So that's going to allow us to argue that triangle ADL is congruent to triangle CBM. That's going to be by the angle, side, angle postulate. And then that's great. If these two triangles are congruent, last but not least, that leaves that AL is congruent to CM by CPCTC. So we have just now proven that AL is congruent to CM by CPCTC. Alright, so let's go over this lesson again. Let's go over this proof again. The first thing we had was that we have really 4 triangles, one shape, one quadrilateral split into 4 triangles. Well, we're given that triangle ABD, this whole first half, is congruent to triangle CDB, this whole second half. That was our first step given. From there, that allows us to conclude that AD is congruent to CB by CPCTC. By that same reason, we can also conclude that angle 1 is congruent to angle 2, which now enables us to conclude that triangle ADL is congruent to triangle CBM by the angle side angle postulate, which then last but not least gives us that AL is congruent to CM by corresponding parts of congruent triangles are congruent. So that's how we got from here to here. I got one more proof and we're done for the day. Kind of a short lesson. Not super short, but it's important you know how to work with more than one pair of congruent triangles, because it will come up. Alright, what's next? What's our final one of the day? Ah, yes. Okay. Let's draw these two side by side. Alright, so I got 2 triangles side by side, each going to about here. Let's see what they call those. RSKT, RSK, and T. What's the next one? XYLZ. XY LZ. Okay. Well, they give us no congruency markers in this case. But let's see what they do give us. We are given that triangle RST is congruent to triangle. That should be a Y there, not an L. That should be Y. There we go. Triangle RST is congruent to triangle XYZ. We're also given some more information. We're given that ray SK bisects angle RST. We're also given that ray YL bisects angle XYZ. What we are seeking to prove is that SK is congruent to YL. So we got several pieces of information here. We're given that triangle RST is congruent to triangle XYZ. We're also given that SK bisects RST and that YL bisects angle XYZ. We need to prove that SK is congruent to YL. So this proof's probably going to be a little bit bigger than what we've done so far today. I know, I saved the best for last. How nice of me. Okay. Some statements and reasons. Alright. First, take one piece of information at a time. That angle RST is congruent to triangle XYZ. That, of course, is going to be by the given information. Alright, so then what's next? We can prove, then, if we have two congruent triangles, there's a couple things. We can say angle R is congruent to angle X. We can say that angle T is congruent to angle Z. What else can we say? We can say that RS is congruent to XY. We could even say that ST is congruent to YZ. How can we say all these things are congruent? By CP/CTC. I just combine them into one step instead of having to write them all separately. CP/CTC. So why don't I go ahead and make my congruency markers? Let's see. R is congruent to X. T is congruent to Z. RS is congruent to XY. And then ST is congruent to YZ. Alright, so now I place some congruency markers on the diagram, which should hopefully make our life a little bit easier. So, what else can we say? There's actually something else we could say. We can say that angle RST is congruent to angle XYZ by CP/CTC. This is really going to come into play in a minute. Alright. Now, we have the fact that SK, ray SK bisects angle RST and the fact that ray YL bisects angle XYZ. That, of course, was given to us for step 3. Alright, well, if these rays bisect, doesn't that mean that angle RSK is equal to angle KST? So, here's how we're going to do this. Angle RSK is equal to half, I'm going to say the measure of angle RSK is equal to half the measure of angle RST, and then that the measure of angle XLY is equal to half the measure of angle XYZ. That's from one we haven't used a lot, the angle bisector theorem. That's the angle bisector theorem that allows us to say that. All right. We're going to run out of space here. This is kind of a bigger proof than I was anticipating. Okay. Step 5, if, alright, so if the measure of angle RST equals the measure of angle XYZ, that means that half the measure of angle RST equals half the measure of angle XYZ. How do we get that? By the multiplication property, of course. That's going to be by the multiplication property. I'm going to bring some statements and reasons over here, okay? Over to the right. Now, by substitution, for step 6, we can say that the measure of angle RSK is equal to the measure of angle XYL. That's simply by the substitution property. So let's go ahead. Let's mark these angles congruent on our diagram, because we've now proven RSK congruent to XYL by the substitution property. Now, do yourself a favor, look only at triangles RSK and XYL. You notice you have an angle, a side, and an angle congruent in each one, right? Therefore, for step 7, we would prove that triangle RSK is congruent to triangle XYL by the angle side angle postulate. Which now, if these two triangles are congruent, for step 8, we can prove SK is congruent to YL. So SK is congruent to YL by CPCTC. So let me go through this proof here. This was a doozy. It was an 8-step proof. So let's start with the first piece of given information, that triangle RST is congruent to triangle XYZ. That was given to us. Now, the next conclusions we were all able to reach for reason 2 being CPCTC, corresponding parts of congruent triangles are congruent. We were able to conclude that angle R is congruent to angle X, angle T is congruent to angle Z, angle RST is congruent to angle XYZ, side RS is congruent to side XY, and side ST is congruent to side YZ, all by CPCTC. Now that we had our congruencies, we use the fact for step 3 that ray SK bisects angle RST and that ray YL bisects angle XYZ. That was given to us. Well, by the angle bisector theorem, we can say the measure of angle RSK is equal to half the measure of angle RST, and that the measure of angle XYL is equal to half the measure of angle XYZ, all by the angle bisector theorem. Which then now we know that if RST is congruent to XYZ, then half the measure of angle RST is equal to half the measure of angle XYZ. That's by the multiplication property. And now for step 6, we can say the measure of angle RSK equals the measure of angle XYL by the substitution property. We can simply substitute those for half the measure of angle RST and half the measure of angle XYZ. And now we can say that triangle RSK is congruent to triangle XYL by the angle side angle postulate. And then last but not least, we were able to conclude that SK is congruent to YL by CPCTC. Corresponding parts of congruent triangles are congruent. So I know that one was a bit of a doozy, but we got there. Those were all necessary steps too. So sometimes these can make for longer proofs, but thankfully there weren't very many of them. But that's it for this lesson. The next lesson we're going to talk about altitudes, medians, and perpendicular bisectors of triangles. So I hope everyone has a good night. Take care.